So we are continuing our conversation about worldviews and things of that nature. Yesterday was a prelude to conversations about evolution and creationism. And so that is our topic today, is evolution and creationism. Move myself out of the way. There you go. So biological evolution is the general idea of biological evolution is that there is no creator, that somehow we got some living thing, and then that living thing changed into other living things, and just like a family has children and the grandchildren don't all look like grandma, these species had daughter species, and the more time you have and the more generations that are present, they all change a little bit and they all look a little different, and eventually over huge volumes of time you wind up with all the diversity of life that we have today. Lots of people had different ideas about how that could have happened. It's often given to Charles Darwin as Darwin is the guy who came up with this. But actually there were lots of other theories about descent with modification and change over time. Darwin was not the first one to propose it. Darwin's idea was the most scientifically verifiable idea. And so his has stuck, quote unquote, although even his view of evolution has changed and been modified and tweaked through time. Various other additions to his theory have happened recently. But the basic concept of natural selection was Darwin's. So there were people as early as the 1200s talking about how species change over time. And we need to be clear that we as Christians don't necessarily say that change over time does not happen. That's not true. Change over time totally does happen. And speciation does happen. One kind of critter can change and become a different kind of critter. But we're talking about small little changes, not about, fish becoming lizards, right? That's not the kind of changes that we're talking about. So change over time, descent with modification, even the mechanism of natural selection is probably true. But the amount of change that is responsible for is something that we differ with naturalists on. Okay, Charles Darwin, just a quick little biography of him. He was an affluent family. He came from an affluent family. His dad, wealthy, well-to-do. His dad was a doctor. His dad expected him to become something important, like a doctor or a priest. And he failed some early math classes, and so his dad said, probably not a doctor. So you should go become a priest, because that's an important career. People will respect you if you go become a priest. So he actually studied. He went to Oxford, and his major was theology. He was going to be a priest, but he really loved science. So he took a break in his studies to become a priest and went on this voyage on a little mapping expedition on a boat called the Beagle. And the Beagle's job was to sail around South America and draw maps of the coastline for future exploration. So he wasn't a map drawer, but he got a job on the boat as the ship's naturalist. So he was there to just see what kind of biological things he could find in South America. And when they got to the Galapagos Islands, they spent a long time in the Galapagos Islands because they had a lot of coastlines to draw, all the different island chains there. And while other people were drawing the island to make maps, he was on the island shooting things and bringing them back to the boat to study and dissect and figure out how these things work. And it was during his stay there that he was impressed by how similar, particularly finches on the Galapagos Islands, were to one another, but different from other finches he'd seen on the mainland of South America. And so that kind of started him thinking about descent with modification and how that could have happened. Now, he was at the time studying to be a priest, which one would assume meant that he was saved and was a believer. But sadly, it's quite common that people study to go work in the church, and they haven't yet had a saving experience with Christ. I don't know if Darwin was saved. I don't know if Darwin ever trusted Christ in a meaningful way for his salvation. He was certainly surrounded by people who did, but his theory was, ran straight up against the idea of the creator. His early editions of The Origin of Species by Natural Selection, his book, the early editions talked about a creator and said that God had created a few kinds of animals, and those animals had evolved into all the myriad versions that we see today. As his book got refined and he released future editions, that language came out of the book. And his final edition of The Origin of Species only references the creator once in the final paragraph. The rest of the references had been taken out of the book. So if that is any testimony to his own personal spiritual journey, he may have acknowledged God in his younger life, but by the time he was an old man, he had turned his back. So that's just kind of his story and how we got there. Here's the basis of his argument. The nutshell of the argument. There exists a large amount of natural variation between individuals of species. So, of some group of critters, one individual is different than another. And you can see that just looking around the room. We're all the same species here, right? Nobody's a Martian. Okay, we're all Homo sapiens, but we're different. We're very different. Differences, and some differences are more meaningful than others, right? Just a superficial scan of the room, we have different complexions, we have different heights, different body masses, different amounts of physical strength, and those may or may not be meaningful in any particular situation. But if we were to be competing for resources, which is the next step of that, then some of these differences that exist between us may become meaningful. So step 2, certain individuals are a better fit to their environment and live longer, healthier lives, leaving more offspring. We live in a technological age, and we live in an advanced society where your physical strength doesn't actually do a whole lot to determine if you get to eat tonight, right? Nobody is out hunting for their immediate needs. Very few of you are going to go through the forest and scavenge for berries tonight, right? So that you can eat. So we rely on the physical prowess of other people. Other people go do that for us, the farmers and the livestock and all that kind of stuff. But if you're not a modern Homo sapien, if you're some other kind of wild animal, then these small variations and small differences between individuals do control how good your life is, right? If we were to turn a bunch of dogs loose in the forest, then the dogs that have really long hair in the jungle out here would get snagged on things and would have all kinds of debris stuck in their hair from running through the jungle, and would be more prone to disease because they're nasty, dirty, and they might get sick and die sooner than dogs with very short hair, where that's not going to be a problem. Or maybe dogs with very, very long hair overheat in our tropical jungles, and they don't live well because they can't get cool enough. But dogs with short hair would do that. So maybe you could see over time that the long hair traits would be selected against. Nature would say, long hair is not a good fit here. Okay? And so certain differences matter in the quality of life of an organism, and specifically in the number of babies that they make. So if you have a longer life, you are reproductive for more time. You have more babies. And so certain individuals that are a better fit to their environment, their particular set of differences gives them a better, longer life, healthier life. those individuals will live longer and have more offspring. And because of that, there will over time be more offspring that carry the traits that make them a better fit. Okay? So that is the argument for natural selection, that given enough time, advantageous differences become more common in a population, and non-advantageous differences go away from a population. Okay? So that is the argument for natural selection. Obviously, it's a lot more complicated than that, but that's the general idea. Okay? So over time, these traits become more and more common. And so as environments change and new variations arise, different features become advantageous and the populations change to fit their environment. So one of the most classic stories of natural selection is the black pepper moth in England. And the black pepper moth comes in two color varieties. Comes in white with a couple of black spots, and comes in black with a couple of white spots. Same species of moth comes in two varieties. You might say two races of moth, right? And so depending on the color variety, you know, it looks different, but it's the same gene pool. They all mate with each other, and the white moths don't keep to themselves. It don't only make babies with white moths. And in England, these moths exist in birch forests, birch groves. Birch trees, if you've ever seen a birch tree, is white with some black lines on the trunk, black scarring on the trunk. So a white moth with some black spots blends in really well on the birch trunk. And he can sit during the day on a birch branch or on the trunk of a birch tree, and birds won't see him because he's blended in. And he can wait for his time to flit about in the dusk and gather his food in the safety of, you know, twilight darkness. But a dark moth that is black with just a couple of white spots, unless he lands on the right part of a birch tree, stands out on a birch tree, not the right color. So a passing by bird goes, "Hey, look, a moth," and eats the moth. So there are far fewer black moths with white speckles than there are white moths with black speckles. Until the Industrial Revolution hit, and England became a place with lots and lots of factories burning coal and belching out black smoke, and for a couple decades, until people started cleaning up their environment, when the Industrial Revolution hit, all these birch trees got sooty and dirty and nasty from all the black smoke of the factories. And now all of a sudden the birch trees are a lot darker. And a white moth with just a few black spots, easy to see. And a black moth with a couple of white spots now blends in. And so the birds flying through a birch forest would now start to eat the white moths, not the black moths. And over time, over the couple of decades that it took for people to start caring about their environment and start having cleaner factories, the moth population switched, where most of the black pepper moths were black with a couple of white specks, and there were very few white with a couple of black specks. So that is an example of natural selection. It was good to be a white moth until there were coal spewing factories. Then it was good to be a black moth, right? And that the dynamic of the population changed in response to a changing environment. That is natural selection. That did happen, and we can look at that and say, yes, look, there's an example of natural selection. But what didn't happen is the moth did not become some other radically different creature, right? It just became slightly different. And that is the kind of change that we would expect to happen. But it didn't become, you know, a caterpillar. It didn't become, well, actually, moth-based caterpillar, so that's a bad example. It didn't become a centipede, okay? It didn't become something drastically different. It didn't become like a honeybee. It became a different colored moth. So environments change, species respond to their environments, stuff changes. Darwin made a proper argument with regard to that. So here's lots of examples, okay? The examples that he saw were these finches in the Galapagos Islands. A species of finch blew, probably in a storm, off of the coast of South America and landed in the Galapagos Islands. And those finches then were isolated from the finches on the mainland. It's too far for them to fly on purpose. So they got there somehow, and once they got there, they were now their own gene pool. And they started adapting to all the different environments on the islands. There weren't other birds on these islands, but there were things that birds could do and birds could eat. So finches diversified and filled all of these open ecological job descriptions, right? The flower eaters, the nut eaters, the bug eaters, the whatever eaters. And they adapted to this changed environment, and there are now, I think the number is 16, something like that, species of finch on the Galapagos Islands that we're pretty sure used to all be one kind of finch. Natural selection. But they're still finches, right? They're just finches with different kinds of beaks. So this finch eats nuts, and it's got a big, heavy beak. And this finch eats bugs, and it's got a little skinny beak for reaching into tree cracks and grabbing bugs. But they're both finches. And yes, we would say this is natural selection. But again, it's on a smaller scale. This is the black pepper moth example I just gave you. This is what used to be the normal kind of moth, and then during the Industrial Revolution, this became the normal kind of moth. And then after England got its act cleaned up again and the birch trees looked white, a couple, like 100 years later, this is now the normal kind of moth again. So, but again, all moths, still moths. And then another classic example that's often given is this example of dogs, where the wolf is the most ancestral kind of dog. And because of human selective breeding, we now have everything from an English bulldog, to the sheepdog, and poodles, and chihuahuas, and everything in between. And oftentimes people say, see, a creature can change, but what's the problem with that? What caused that? An intelligent mind saying, I don't want a wolf, I want a poodle, right? And over this course of generations, selectively breeding towards something like a poodle, which I don't understand why anybody would want, but okay. And so there's an intelligence involved in that. This is a lot of change, but it's a lot of change driven by a mind, not by random natural events. It's something, yeah, from which we now have wolves and foxes and jackals and Australian hunting dogs and teacup chihuahuas. Yes. So this is the example of that's more local. Do you guys recognize any of these birds?
The red bird.
These are all versions of honeycreepers. So in the Galapagos Islands, it's finches that blew onto the island somehow and then diversified. And Hawaii has a similar story with honeycreepers. We have, we are a long ways away from any land mass. And these birds are not migratory. They are not honeycreepers. They're not birds that fly thousands of miles to go find a new place to nest. Somehow, a group of honeycreepers got here. In a storm, on a drifting piece of wood, somehow honeycreepers got to the island. No other birds here, or very few other birds here. And so they exploded in diversification. And we have all of these creatures living in Hawaii, and probably all related to an ancestor that came here at some point. So natural selection is a true story, but we need to make sure that we understand that it's small-scale change, right? Small-scale change can be seen. It is a real thing. To be a creationist does not mean you don't think that things change. Things change. But they change on a small scale. And so we are comfortable with what we can readily see around us, which is microevolution, small changes. Small changes. Large scale change, and we would use the phrase macroevolution, is an inference from microevolution. So let me explain that to you. People look around themselves and they say, hey, look, there's these moths that change color over the course of a century. Hey, look, there's all these finches that are probably all descended from one species. Hey, look at all these honeycreepers that we have in Hawaii that are all descended probably from a species. Look at all these diverse kinds of canids out there, dogs-like creatures, wolves and foxes and jackals and hunting dogs and teacup chihuahuas. And we say all of this small scale change is legit. It happens. It's true. The jump to macroevolution is somebody saying, this is true on a small scale. I bet it's true on a big scale. But we can't observe, we cannot test, we cannot verify, we cannot experiment on anything that proves macroevolution. Macroevolution is an extrapolation, a going beyond the evidence to say, well, if this works, then this must also work. And so it's a logical step to make, but it is not a step that is provable. You cannot demonstrate macroevolution. So macroevolution would be statements like, there were once fish, and then some fish had really rigid fins with bones in them. And those rigid fins with bones in them allowed them to waddle out of the water for certain amounts of time, and they discovered rich food sources on the land that no other animal was eating. So it was good for them to be able to push themselves out of the water on these fins and eat, and then return to the water. And that was good, so those fish had more babies. And over time, that trend led to salamanders, which are born in the water and come out of the water and live their life on land. And then there was this amazing random event called the amniotic egg, and it allows these salamanders to not have to lay their eggs in the water. They could lay their eggs on the land, and the babies could hatch and survive on land. Now you have a lizard, and it's amazing. And this just happened. And the lizard then, got bigger and bigger and bigger, and some lizards started jumping from tree to tree, and those lizards were able to catch things faster because they didn't have to crawl down the tree and over and up another tree. They could just jump. And the better jumpers started jumping further, and eventually there were little flaps of skin between their fingers and their sides that let them kind of glide. And then eventually those got bigger, and now we have pterodactyls, right? And pterodactyls were the studs of the air because they were the first ones to fly. So all kinds of new food sources available to them, and they had more babies. And then over time, if you fly to far places where it's cold, it's really good to have more than just scales. And eventually there were feathers. Somehow feathers came to be. I don't know. They poof, feathers. And feathers covering a pterodactyl made it a bird. And now we have birds. Isn't it incredible? And then some of the animals that didn't get to fly, those lizards that didn't get to fly, the lizards that stayed on the ground, those lizards became faster and faster and faster and chasing more and more prey. They were better hunters because they were faster, but a lizard can only run so fast because it doesn't have a good metabolism. And if you're digesting a lot of food and you're eating a lot of food and you're burning a lot of calories, you're a mammal. And all of a sudden we have dogs instead of lizards, and it's stupid to hear the story told that way, right? But that is macroevolution. That is macroevolution. Microevolution is honey creeper becomes lots of honey creepers, but they're still honey creepers. Macroevolution is fish becoming dogs, right? And so that's the difference between the two. This is the story of the bird that I just told you, right? A lizard that can jump and eventually gets feathers, and then now we have a blue jay. And that is the concept of macroevolution. Okay? So, biblical creationism is obviously a different story. We are all very familiar with the creation account in Genesis. One of your menu assignments is to look at other verses in the Bible that teach the doctrine of creation. There are over 300 times in Scripture that God is declared as the creator, the creator of man in general, and the creator of man in particular. And I gave you an address here. You don't necessarily have to write it down if you don't want to, but if you're curious, gospelway.com has a list of more than 300 verses in the Bible that says God made things. Okay, pretty awesome. And biblical creationism says, creation is ex nihilo. Ex nihilo means out of nothing. Out of nothing. Genesis 1:1 says, in the beginning God created the heavens and the earth, which means that before that happened, there were no heavens and the earth. God did not stumble across the universe and say, ooh, I can do something with that. God existed when there was nothing, and he spoke it into being, and it came into being. Okay? So, there was historically, there were a group of scientists, and not just a group, there was a dominant belief amongst materialist naturalist scientists that the universe had always existed. The universe was always there. It's an eternal phenomenon. And so they didn't need to ask how did the universe come to be. They would say the universe is eternal. The universe just is. But then through the discoveries of various astrophysical phenomena, we are confident that the universe had a beginning. And the scientists that worked on the Big Bang Theory, while the Big Bang Theory does not exactly line up with Genesis, it does teach that the universe had a point of origin. And the spreading and the acceptance of that idea amongst scientists has made them have to ask the question, where did the universe come from? And the answer to that is nothing within the universe can create the universe. So none of our natural forces, none of our natural laws, none of the things we can see could have made the universe, because all of us are part of the universe. So there has to be something outside of the universe that made the universe happen. And we know that's God. That's Yahweh. So the creation out of nothing, ex-nihilo. And there's just, if you search for creation out of nothing, there's all kinds of cool images on the internet that describe that. There are a couple of non-literal interpretations of creation, but the Bible clearly teaches 6 literal days of creation. And this is something that I used to hold pretty lightly. I used to say, hey, yeah, if you believe in 6 days, that's cool. If you believe in 6 ages, that's cool. If you believe in 6, days that are spread out over the course of billions of years, that's cool. But the more you study theology, the more you study how much of what we believe about God is based on the fact that he made it all the way he said he made it, and that nothing died before the fall. You have to believe that God meant what he said in Genesis 1 and 2. So in my own life, there was that point, and it's been maybe 5 years ago now, maybe not that long, 4 years ago now, where I came to the discovery in my own life that I believed literally everything the Bible said from Genesis 3 to the end of the book. I didn't question miracle. I didn't question anything else. I believe in the Tower of Babel. I believe in the global flood. I believe in the resurrection of Christ. I believe in the virgin birth. I believe all of these things that are just amazing and require God to be incredible. But I had a hard time with Genesis 1 and 2. And I had a hard time with a 6 literal days about 6,000 years ago, accounting for all of the evidence of the fossils and stuff. But my problem was that I had man's knowledge and God's knowledge, and I was saying that they are of the same value, and I said this yesterday. But there came a point when I realized that what God tells us is a different level of truth than anything we can come up with on our own brain. So my problems with Genesis 1 and 2 didn't have anything to do with it being inconsistent with God. It had to do with being inconsistent with what man had coughed up out of his broken, fallen brain. And so I had to say, no, I'm going to ignore the parts of man's knowledge that argue with the Bible, because the Bible is a higher form of truth. And I was being inconsistent by saying I believe every word of Genesis 3 forward. I have a hard time with Genesis 1 and 2. If God is trustworthy from Genesis 3 forward, he's trustworthy in Genesis 1 and 2. And so I made the transition in my life to being a young earth creationist, believing in 6 literal days of creation, somewhere around 6,000 to 10,000 years ago. And I'm very happy and relieved that I was able to make that decision in my life. Not because I think I'm a better scientist, but because God is trustworthy. And if God told us something, then God is to be believed. And that is such a simpler way of looking at the question than saying, well, how do you deal with all of these data? The data don't self-interpret. You can look at the data and believe in the young creationism, just like you can look at the data and believe in billions and billions of years. But you have to decide, can you trust God? And I came to the conclusion that I could. There's various points of theology that base themselves on literal creation. Okay, it sets the standard for interpreting the rest of Scripture. If you doubt Genesis 1 or 2, and you think you have to help God describe what He did in Genesis 1 or 2, then you're going to help God describe what He did everywhere else in the Bible. And when you come across something in the Bible that's incredible, you're going to say, "Oh, that must not really be what happened." Right? If you start questioning the beginning of the book, then you get to the virgin birth, and you're like, "Well, I mean, come on, virgins don't have babies, right?" So what really happened is the word there is not partheon, meaning virgin. The word is pantheon, meaning she slept with a soldier, and that's why Jesus was, it's not Joseph's son. We all know that, but it's some Roman legionnaire who had a good time with Mary, and she just told everybody he was an angel. And that's actually out there. That's totally true. That's absolutely out there. And then you get to the resurrection of Christ, and you're like, well, but dead people don't come back from the grave. Even really good people, even people who are filled with the Holy Spirit, don't come back from the grave. So Jesus just kind of passed out from the loss of blood. And the fact that he had been wrapped in some linens helped control the bleeding, and he was laid in a cool place where he could recover. And after sleeping off his crucifixion, he was able to move a 500-pound rock and overcome 6 soldiers. That's how well he recovered from his crucifixion. And that's why he was able to appear to the disciples. No, but the problem is, if you start editing from the book, you're going to keep editing for the rest of the book, right? And the fact that the Bible restates creation 300 times. Definitely, the Bible means to say that God created the heavens and the earth, right? The Word of God teaches us everything we need to know about God. And the doctrine of creation really is the foundational doctrine to everything else that we believe, right? You can't stand up and be a strong voice for the authenticity of the Bible and talk about why we should only have marriage between a man and a woman because the Bible says so. If you don't also say, I believe that the earth was created in 6 days, about 6 to 10,000 years ago. If you don't say that, then you are someone who questions the Bible, and you have no right to argue anything else based on the Bible. It's the first thing the Bible talks about, and it is the foundation for everything else that we believe. Okay, so we have to get the order right. Noah's flood. Noah's flood plays a role in interpreting the dead. The fossil column either tells the story of billions of years of history and lots of death, or of one global flood during which most of life perished. So you have tons of dead things, and you find layers of the same kind of dead thing. If you go to a certain structure in the fossil column, you expect to see a certain group of dead creatures. And if you go deeper than that or higher than that, you don't see the same dead creatures. You see different dead creatures. And the reason for that is either because when the layers of rock were being laid down, there were these kinds of animals living on the earth. And when they died, they got buried. And at some point, they went extinct, and some other form of life replaced them. So higher on the column, you see other forms of life. Or it could be that everything was covered in a tumultuous amount of mud and silt and water that is incomparable. You can't believe how much water and turbulence and silt and mud and rock there was in the flood. And a particular type of body, because of its density, because of the animal's ability to swim or not, because of whatever else was going on in its body, When those things died, they stayed suspended in the water for a certain amount of time, and then they began to settle out. And everything of a particular body plan settled out at about the same time. And so they got buried at about the same depth. And other kinds of things were still either surviving and struggling in the water, or were floating because they had more gas in them. For whatever reason, they hadn't settled yet. And as the mud and the layers were laid down, similar sorts of bodies settled out at similar times. And so you wind up with similar sorts of creatures at similar layers. That both of those are possible answers. And so you look at the data, and the data doesn't tell you which of those it is. You have to interpret that. But if somebody ever comes and tells you that the Earth cannot be young, and things have to have had macroevolution because of the fossil columns, they're looking at the data through their worldview, and they're telling you that your worldview doesn't work. But in fact, either of your worldviews can interpret the same data. Okay? Many features of the geologic record support the existence of a global flood. And we're actually out of time, but I just real quickly, and then I'll let you go. There are things about the fossil record, about the geologic column, that can't happen slowly. If you go to the Grand Canyon where I used to live, I lived like 40 miles. I lived like 40 miles from the Grand Canyon in Flagstaff. You go there and you can take tours of the Grand Canyon, and literally you can take the exact same boat on two kinds of tours. You can take a boat tour down the Grand Canyon, down the Colorado River, and have a tour guide show you rock structures that took billions of years to make. And the lecture is all about how the Earth is old, and look at the amazing fossil record displayed to us in the wall of the Grand Canyon. Same exact boat, leased by a different company with a different tour guide. You can get on the same boat and have a different lecture going down the Colorado River with somebody pointing to structures and saying, look at the evidence of the flood. It's the weirdest thing. Okay? Just depends on which company leases the boat for that day. Okay? And at the end of one tour, you're convinced that the Earth is billions of years old. At the end of the other tour, you're convinced the Earth is 6,000 years old and there was a flood. It's amazing. And so some of the things that the flood guy points out are fossilized trees that grow up through layers of sediment. And the billions of years guy will say there was a tree that was fossilized, that was petrified. And somehow the tree stood up on end as a petrified fossil. If you ever see fossilized trees, they're always laying down. They've been covered by mud, they've been knocked down. They never petrify upright, right? But there are upright, petrified trees with layers of rock, and the billions of years guy will say that this layer of rock is hundreds of millions of years older than this layer of rock, than this layer of rock, but there's a petrified tree that goes through all of it. Well, either that is the oldest tree the world has ever seen, and that tree is hundreds of millions of years old, or there was a tree, and there was a flood, and there were layers of mud laid around the tree, and the tree petrified while all of this other stuff was going on, right? Seems like, at least in that example, the flood guy wins. So you need to be aware that the data does not self-interpret. Your worldview controls how you see it. Okay? So we will talk about this more. Thank you for giving me 2 more minutes of your life. God bless you all. See you tomorrow.